Alright guys, welcome back. So our last topic, 6.6, is graphing tangent and cotangent functions. We've talked about sine and cosine, we've talked about cosecant and secant, now we have tangent and cotangents. So their curves are a little bit different. They're not going to be the same oscillating wave, but they are a bunch of repeating curve shapes going on here. They're split up by vertical asymptotes, and the curves themselves kind of being going up all the way for a tangent or going down all the way for a cotangent. So the basic form, again, you should recognize you have the a in front of the tangent or cotangent, b factoring away of theta minus c plus d. So again, the horizontal and vertical phase shifts, it's the exact same process before. Everything is still the same for the whole shifting idea. There is also no amplitude for these, like for cosecant and secant, because it's going on forever in both positive and negative directions at the vertical asymptotes. Therefore, we don't have to worry about an amplitude. What's different now is the period is pi over b rather than 2 pi over b. Okay, so you need to be very careful with that. Your period is based on pi over b, not 2 pi over b. And to graph these things, all we're looking for is where the vertical asymptotes will occur and where the midline point is, because those are the only things that actually matter. Because it's going on forever in both directions after the midline point. We just know where that is and where the asymptotes are to make our shape. We do need to watch out if a is negative, because if I go back a second, so our tangent graph looks like this right here. This is when a is a positive value. If we still have tangent but a is negative, the graphs will be very similar. So we have pi over 2 and negative pi over 2 are the basic vertical asymptotes. 0 is your basic midline, but now the curve will go down like this. And the same thing for all the other ones. Cotangent, same thing. It's going to be flipping. Rather than going down the whole way, it's going to go up the whole way. So we do need to pay attention if a is positive or negative. Beyond that, it does not affect anything else, because we're not using a to identify anything else in the problem. Now, for the vertical asymptotes, based on which function is, determines where they start. Tangents will start at the half period value. Cotangents will start at the origin itself. Each new vertical asymptote will be the same distance away, equal to the period. And for each of these, we're going to use 3 vertical asymptotes. The first one being at either the half period value for tangent, origin for cotangent, and then we're going to go 1 vertical asymptote in the positive direction, 1 vertical asymptote in the negative direction. If there is a horizontal phase shift, that'll move where those vertical asymptotes are going. If there is a vertical phase shift, it's not going to change at all because the vertical asymptotes are, by definition, vertical lines. Shifting up and down doesn't change the location of a vertical asymptote. Only shifting left and right does. For the midline points, it now switches. Tangent starts at the origin for a midline. Cotangent starts at the half period value. Same thing with the vertical asymptotes. In fact, you're going to find the midlines are just simply in between the two, in between all your vertical asymptotes, the exact middle of it. So in reality, as long as we can plot the vertical asymptotes correctly, the midlines are just in between there. We're again going to be using 2 points for that. You'll recognize there'll be one before and one after the starting point of 0. Like with the vertical asymptotes, if there's a horizontal phase shift, it will just simply move the point left and right. This time the vertical phase shift will shift it up and down, so we'll move up and down for that particular midline point. Alright, so we're going to take a look at 4 tangent of 2 theta. So all we need to identify from here is the period itself. So the period is just pi over 2, pi over b. Not 2 pi like sine, cosine, secant, and cosecant, just pi over 2. So when we create our graph, we want to have it evenly spaced here. So we're going to recognize that we want to have our half period, then full period. So the half period would be pi over 4. Full period would be pi over 2. And on the negative side, we're going to need the negative of it, so it'll be a negative pi over 4. And then we're also going to need one more point on the other side, which will be then 3 pi over 4 following that pattern, because they're going up by pi over 4s. And the reason why we need all of that is because the actual graph has vertical asymptotes again at the half period value, which is pi over 4. And then we need to have 2 other vertical asymptotes in the positive direction, adding on the period. Well, pi over 4 plus pi over 2 is the 3 pi over 4. That's that second one there. And then subtracting, going the opposite direction, that's negative pi over 4. And in the middle is 0. And the middle is pi over 2. And since it's tangent, we're just going up. And there we go. Going up. There's our tangent curve. So in a lot of ways, there's a lot less work really to do with the tangent and the cotangent graphs because we're finding really less points. It's more about where are the vertical asymptotes, the three of them we want to work with, and then the midline points are in between there, and then that's really about it. Obviously, when they're shifting, there'll be a little bit more effort involved there, but for the basic functions, it's really not going to be that bad. All right, so let's take a look at another one. So we have a positive 3 here, tangent of theta over 4. So our period is pi divided by 1/4. Pi times 4 over 1 is just 4 pi. So we set up our graph. We need 3 points on the right side and 1 point on the left side. The 3 points on the right side start with the half period, which would be 2 pi, and then the full period, which is 4 pi, and then adding those two together to get to the next point is our 6 pi. And on the negative side is just simply reflecting, so it's a negative 2 pi there. And again, the vertical asymptotes occur at the half period, and then every other space, so then it's going to be at 6 pi skipping over 4, and then going the negative direction, going to negative 2 pi. Where again, the midline point's now in the center of those two, and its tangent, it's a positive 3, so it's going upwards. So our shape is just kind of looking like this right here. And there we go. There's tangent. Cotangent, very similar process there. We're just going to recognize that we have 2 cotangent of theta over 5. So our period is still pi divided by 1b, so 1/5. Pi times 5 over 1, 5 pi. Now for this one, it's a little bit more symmetric there. We're going to find that there are going to be 2 points on the positive side and then 2 points on the negative side. So the 2 points on the positive side would be the half period, 5 pi over 2, and the full period, 5 pi. And as always with the negative axis side, it's always reflective, so this would be a negative 5 pi over 2 and a negative 5 pi. The vertical asymptotes will start at the origin, so on the y-axis. And again, it skips 2 spaces, so then it'd be at 5 pi and negative 5 pi for the other 2 vertical asymptotes. Midlines are in the middle, but these, because it's cotangents, are going downwards. So it's going to look like this right here. All right, so for our next cotangent 1, and you should be noticing right now, really for the tangent and cotangents, the value of a in front really is irrelevant for the actual number based on what we're doing for our sketches. If we wanted to find additional points besides the midline point and the vertical asymptotes, that 6 or that 5 or the 2 or whatever's in front would kind of matter. For now, we're only focusing on based on if it's positive, what that shape means, if it's negative, what that shape means. So again, our period is pi divided by b, so it'll just be pi over 4. For our cotangent graphs, we know it's going to be symmetric, so we're going to have 2 points on the right, 2 points on the left. The point on the right is going to be the half and then full period, so half of pi over 4 is pi over 8, full period is pi over 4, so then it's the negative pi over 8 and negative pi over 4 on the opposite side. Our vertical asymptotes are going to occur at those endpoints and the one in the middle on the y-axis, so at those full period values in the y-axis. And then our midline points occur again in the center of that. Cotangent's downward shape as long as a is positive, so it's going downwards. And then same thing on the other side. So those are just your basic sine and cotangent, basic tangent and cotangent graphs. Now when there's the shifting going on, it's going to be the same kind of process for shifting that we've already dealt with. We're going to recognize that we're going to pretty much graph this thing based on just negative 2 tangent of theta over 3, plot our points based on that, and then shift the points around based off the horizontal and vertical phase shifts. So again, our period is just simply pi divided by b. So it's pi times 3 over 1, which is 3 pi. When we're plotting our basic points, it's going to be a plus. We are going to shift it left, so we do want to give ourselves enough space there to shift left. Our original points, we need 3 points on the right side and 1 point on the left side. Or again, the first point on the right is the half period, so half of 3 pi is 3 pi over 2. Next point is the full period, 3 pi. And then if we add those two together to get to the next one, it's 9 pi over 2. And on the negative side, it's negative 3 pi over 2. So the original points you're going to have, and I'm not going to do the full thing, but again, there was going to be vertical asymptotes occurring at the negative 3 pi over 2. at the positive 3 pi over 2 and at the positive 9 pi over 2, and then points at 3 pi and 0. Now for the shifting, we're factoring the 1/3 away from theta and from pi. So if we're doing pi divided by 1/3, we're getting pi times 3 over 1, which is 3 pi. So our horizontal shift is 3 pi to the left, which we can recognize based on this information right here means each point is going to shift 2 to the left. Because of that right there, so it's 2 spaces. And our vertical shift is 3 up. So we are going to need 2 more spaces over here, so we are going to need a negative 3 pi and then a negative 9 pi over 2 for the whole symmetry aspect. So for the vertical asymptotes, they're shifting over 2 spaces, so they're shifting over the negative pi over 2. And then they are going to shift over the 3 pi over 2 is going to shift over to negative 3 pi over 2. And the 9 pi over 2 shifts over 2 spaces to 3 pi over 2. The points themselves are going to shift again over 2 spaces, but now up 3. So the midline now goes here, and the other midline can go right there. Now, tangent is nowhere in upward-facing shape, but now it's a negative 2, so now it's going to be like cotangent where it's downwards facing, where it looks like this. All right, so that's what our shape is going to look like for our tangent curve. Again, we identify the horizontal shift based on the information given to us, and then we get to go at it from there for where everything is going to move around. All right, so let's take a look at another one. So this one we have negative 4 tangent of 2 theta minus pi, so this one's going to shift right this time. Either way, we focus more on what negative 4 tangent of 2 theta looks like, so it's pi over 2 for the period. So we again have our 3 spaces on the right side, 1 space on the left. We have our half period, which is pi over 4, full period pi over 2. If they add together, we get 3 pi over 4. And then we have our negative pi over 4 over here. Where again, originally we had vertical asymptotes at negative pi over 4, positive pi over 4, and 3 pi over 4, with points at 0 and pi over 2. So now we got to figure out the whole shifting business. So we factored 2 away from theta and from pi. Pi divided by 2 becomes pi times 1/2, which is pi over 2. So the horizontal shift is pi over 2 to the right, which is going to be 2 spaces. So we need to add on 2 more spaces to the right. So we're recognizing going up by pi over 4. So this space would be at pi, and this would be at 5 pi over 4. Our vertical shift is going to be 1 up, because it's a plus 1, so it's 1 up. So the vertical asymptotes, again, we don't shift up or down at all. We just shift them right 2 spaces. So the first one goes from negative pi over 4 to positive pi over 4. Pi over 4 then goes to 3 pi over 4. 3 pi over 4 then goes to 5 pi over 4. The midline points are going to go up 1, so they're going to shift over again 2 spaces and up 1. And then again, they're going to go over 2 spaces and up 1. They're going to stay in the middle of those things. So really, just you want to go in the middle of the vertical asymptotes and then plot at the correct value, which is this number here at the end. The value of A is again negative, so tangent's going to do like cotangent and go downwards. And again, if you're ever unsure, you can just simply graph the basic negative 4 tangent and see what shape it looks like going down or going up, and then that will apply to the same way no matter what theta is or whatever the minus shift is or whatever's going on. Cotangents, you'd have to do negative 4 divided by tangent then, because cotangent's the reciprocal of tangent. All right, so now taking a look at the cotangent curves. We have negative 3 cotangent of 5 pi plus 5 theta plus pi here. So we go ahead and do our period, 2 pi over 5. Can't do anything else with that. So we plot our original points. Again, it's originally symmetric. We have 2 points on the right, 2 points on the left. The quarter period would be, or half period, sorry, would be pi over, this should have been just pi over 5, not 2 pi over 5, because it's pi over b. So this is pi over 10 for the half, pi over 5 for the full. Negative side is negative pi over 10 and negative pi over 5. So for the original, without the shifting, we have vertical asymptotes at pi over 5, at 0, and also so at negative pi over 5, 0, and positive pi over 5. With midline points here at negative pi over 10 and positive pi over 10. So based on the shifting, we again factor away the 5. Doing theta divided by 5 would be, pi divided by 5 would be pi times 1/5, which is pi over 5. Which means our horizontal shift is pi over 5 to the left because of the plus sign. Pi over 5 is 2 spaces, so everything's going to go 2 spaces left. So we need 2 more spaces over here. So this would be a negative 3 pi over 10, and then a negative 2 pi over 10. We can recognize our vertical shift is the number that's subtracting at the end, so we're going 2 down. So each of our vertical asymptotes are going to shift over 2 spaces to the left. So it was at negative pi over 5, it's now going to be at negative 2 pi over 2 pi over 5, not negative 2 pi over 10. It's going to shift from 0 to then negative pi over 5, and then shift from pi over 5 to 0. The midline points are going to go down 2 and just be in the middle of those things, so it's going to be right here at negative 3 pi over 10, and here at negative pi over 10. Cotangent was downward facing, but since it's negative, it's going to be upward facing, so the shape is going to look like this right here. Alright, so again, it's all about shifting around. As long as you're comfortable with where the original vertical asymptote points are, where the original midline points are, in the middle of the vertical asymptotes really, then it's really not going to be that bad. And again, the vertical asymptotes start at the origin for cotangent, and they're just separated by pi, not pi the period. So that's how we went up to pi over 5 for the next one, back to negative pi over 5 for the other one, and then we're shifting around the same kind of way we shifted everything else around. Alright, so one last example. If you haven't tried one on your own yet, you really should try this one on your own. So we're going ahead and identify our period. Pi divided by 1/2 is pi times 2 over 1, which is 2 pi. So we go ahead and make our graph. We again have 2 spaces on the right side, 2 spaces on the left side. First space is the half period, which is pi, so then 2 pi for the full period. On the negative side, it's negative pi and negative 2 pi. Where again, we've got vertical asymptotes at negative 2 pi, at 0, and at positive 2 pi. And then we have points at negative pi and positive pi. As for the horizontal shift, we're again factoring out the 1/2 from theta and pi over 2. So doing pi over 2 divided by 1/2 means we're doing pi over 2 times 2 over 1, which is just pi. So horizontal shift is pi to the right. Pi is only one space, so they're only shifting one space to the right. And on our vertical shift, we're going to go 1 down. So we need only one space to the right, so we can go to a 3 pi here. So we're going up by pi's. The vertical asymptotes are going to shift only one space over, so it's going to shift from negative 2 pi to negative pi. 0 shifts to pi, and then 2 pi shifts to 3 pi. The midline is again in the middle of the vertical asymptotes at the negative 1, so it's going to be right here and right there. Cotangent's downward facing, but because it's a negative, it's upwards facing. So the curves look like this. And there's our final cotangent graph. Okay, so, and as I was saying really from the beginning for each one of these graphs, this is just simply one way, my preferred way of graphing these points. They're based on the original curves and then kind of shifting around. And again, I have these set up so that the shifts are nice shifts and matching up with the period in some way. They're not going to always be nice shifts, so be aware of that. All you're doing is literally adding on or subtracting on by the shift. So it just becomes a little bit more work there, but it's really the same kind of process. That's it for Unit 6. Unit 7 is still trig, but now we're going to get more into trig identities, trig properties, and then we're also going to talk about solving trig equations, as well as everyone's favorite thing, trig proofs. That's in Unit 7. You guys have a good one. Thank you for watching.